So hey nerds, this is Suman, and in this video I'm going to talk about the combined effect of electric and magnetic field in an atom. And I'm doing it in classical way or in quantum mechanical way. I don't know, but I am going to share my own idea. So you have already knew that if you had watched my two lectures that whether I have to tell it my lectures or my work, there in Zeeman shift, when you apply external magnetic field in an atom, the frequency of emitted photon will vary, because instead of getting a single spectral line, we are getting multiple spectral line. And similar manner is seen in the Stark effect. So the Stark effect is basically when you apply electric field to an atom, again the spectral line splits into multiple component line instead of giving a single spectral line. So I am going to deliver my idea how to evaluate the spectrum of emitted photon if we apply external electric and magnetic field in an atom. So let's dive into the whiteboard. So in order to understand the behavior of atom in external electric and magnetic field, whether we have to call it as cross field, let us assume that the nucleus is at here, and someone of my brother telling that you are doing your mathematics in the classical idea. So I'm assuming that this is the reason where we will find the probability of getting electron. So I am doing something quantum mechanical, right? If I make that sense. So I am telling you that we have to apply electric and magnetic field, external electric and magnetic field within this atom. So let us assume the probability of finding electron is here. Are you with me? Yes. Okay. The probability of finding electron is here, and the velocity of electron could be in either direction. It could be in that direction, or it could be in this direction. This is velocity vector, right? So now I am applying magnetic field. So when I apply magnetic field in inward direction, so this is the magnetic field, this symbolizes the magnetic field that is going into the plane of the board. Like some arrows are hitting here like this. So if you know the Lorentz formula, so Lorentz formula is, I think the Lorentz formula is the combination of electric or electric as well as magnetic field, but I know the magnetic field acting upon a charged particle is nothing but V cross B. Let me see it in whether it is coming in the board or not. Yes, it is actually coming. So the magnetic force actually is inward direction. So if you know the basic physics, you have to know about the cross product. So if the velocity is in this direction and the magnetic field is in this direction, so the V cross B, right? V cross B would give you the magnetic field in this direction if the velocity is in this direction. So does if your velocity is in that direction, the V cross B gives you magnetic field in this direction, right? So magnetic field could be in either of direction. We don't know how the electron is moving across the nucleus, so we are assuming these two scenarios. And we all know that the centripetal force is acting upon the nucleus if the orbits are, let us assume for an instant, they are circular. So the magnetic force acting upon this charged particle, the centripetal force acting upon the charged particle is in downward direction. So you can see from here, the centripetal, you can see here, the magnetic force could be in support to the centripetal force, or the magnetic force is opposing the centripetal force, right? This is the case. I am just doing very simple manner. I am trying to convince you. So I have applied magnetic field within that atom. So now what I have to do? So now I have to apply electric field. So does I have to provide a cross field. So let us apply some potential across this field. Let us apply some potential across this field. So now what will happen? So if you know the magnetic force could be in support and could be in opposed to the centripetal force, the electric force. So I'm not a good animator, right? So I have to build some vector arrows in that direction, in those directions, in order to convince you. So if the electron is here at any instant, the electric force would be acting in this direction, right? The electric field force could be in that direction. And for any instant, if the probability of finding electron is here, the electric force is in this direction, and the centripetal force is always acts towards the nucleus. So you can see from here that if the electron is here, the electric force, the external electric force is opposing this centripetal force, right? And if the electron is here, the external electric field is supporting the centripetal force, right? This is, I think this is clear to you. So what do you have to do now? So can we draw the resultant force acting upon the charged particle due to combination of electric and magnetic field? Yes, of course. So you are knowing that the centripetal force, the two other forces, electric and magnetic force, would support centripetal force or oppose centripetal force, right? So you have known that, and this is just a scenario. And so if I have magnetic field in this direction, and if I have velocity in this direction, so velocity could be in this direction. So V cross B gives you a magnetic field in this direction, right? And if the velocity is in this direction, I'm not doing from here, I'm doing from here because this looks more complicated now. So the magnetic force could be in this direction. But our applied electric field, let us see our applied electric field. The applied electric field would be in this direction. So you can make a beautiful assumption here. The resultant force the electrostatic force and magnetic force would support each other, or the electric force and magnetic force will oppose each other, right? So the resultant can be written as the electric force plus minus magnetic force. Why I'm writing plus minus? Because if it supports magnetic force, we have to use plus sign, and if it opposes the magnetic force, we have to use minus sign, right? This makes sense, I guess. So there will be some chances that the two forces are in same direction, and there is some chances the two forces are in opposite to each other, right? So the resultant of electric and magnetic field is this much. The resultant force is this much, right? So this could be the resultant force, and what about the resultant force acting upon the charged particle? So the resultant force could be in either direction. It could be in this direction or it could be in this direction. The centripetal force is always acting towards center if this is the charged particle, and the resultant force could be in this direction, in upward direction, opposing it, or could be in supporting it, right? So if you know, the net force acting upon the charged particle can be written as the centripetal force plus minus this much of force, Fe plus minus Fm. You can write both Fe plus minus Fm or Fm plus minus Fe. It doesn't make any mistakes. And when you apply some force to something, there will be some slightly change in velocity, right? And the particle is, if it's doing circular motion, then it will absolutely going to change its angular velocity. So it would be mr omega plus d omega square. Are you with me? And if you're getting my point, so you can write it, if there is no external electric and magnetic field, the electrostatic force due to nucleus is equal to centripetal force, that is mr omega square, and d omega is slightly change in angular frequency in presence of electric and magnetic field, and this d omega is change in angular frequency of electron, okay, not the shift in angular frequency of photon. So this would be mr omega square plus minus, you can write Fe as EE, charge on particle, and how much field strength are we applying, plus minus, and you can write it as this much. So Q can be replaced as charge on electron E, V, B, and this would be mr, and if you open that whole square term, you will end up getting something like this, and the d omega is very small quantity, and if you square the very small quantity you will again end up getting very small quantity. So I am neglecting this term as it tends to 0. So now I am getting mr omega square plus minus ee plus minus evb, mr omega square plus 2mr omega d omega, and this mr omega square will cancel out each other, right? So are you with me? So this would end up getting plus minus ee plus minus. So if I take both e common, I will getting e, I am writing e vector, right? Okay, plus minus v cross b vector, v cross b vector, and this is 2m, and r omega is nothing but the linear velocity of particle, and you can write d omega is 2 pi f. So plus minus e vector plus v cross b vector equals, if you take 2 pi out of this differentiation you will get 4 pi mv df, right? So plus minus e vector plus minus v cross b by 4 pi mv equals h df, sorry df. So are you with me? I guess so. So my ink has completely gone. So now I am assuming that the particle also obey Planck's radiation law. So I am doing plus minus, I am adding h on both sides, and this would be e vector plus minus v cross b vector by 4 pi mv, and this is h df. I am taking negative here and then making plus minus is minus plus. So why I am taking negative here? Because the total energy of electron within a nucleus is quantized and it is negative. So this could be the change in energy. So if you know E is equal to hf, and if you want to find the change in energy, you have to find h, change in frequency, right? So the change in energy, the shift in energy would be plus minus. So EH upon 4 pi m can be written as mu b, and this is E vector plus minus V cross B vector by V, right? I guess so. So I want to tell you the very important thing about this term. When you apply external magnetic field in an atom, within that current loop, right, within that loop, an external induced EMF will generate. So I will tell you the very simple definition about the vector calculus. If this is electric field, if this is something, if this is apple, that is adding or subtracting, there must have to be also the apple. So if this is apple, this must also have to be the apple, because the dimensions of this, if something is adding to something, you can add apple to apple, you can add mango to mango, but you cannot add mango and apple. So if this is electric field, this term V cross B must have to be the electric field. So I had some idea about Faraday law of electromagnetic induction, and I am doing something very much important conclusion, that so this is electric field, I am writing it as E applied plus minus. So V cross B, so V can be in any direction, so V cross B could generate induced electric field in this direction, or if velocity is in this direction, the induced EMF will be in that direction, right? So the induced EMF could be in plus or minus direction. So E induced vector by V. So this also is a velocity, I can write it as V vector. It doesn't make any difficulties in our calculation. So if you get my point, if this is apple adding or subtracting with something, there must have to be the apple. So V cross B induces an electric field within that atom, right? Okay. So this is the energy shift of electron. So I can write it as, let me do here. So dE can be written as plus minus mu B. So if applied electric field would be in positive direction, it will end up getting some positive quantity, and it will be add up, and if it in negative direction, it will be subtracted. So I can write it as E resultant vector by V vector. So these both are vectors and they will cancel out each other's. Right? So are you getting my point? Why I am using a resultant? Because the induced field could be in direction of applied external electric field or could oppose the external electric field. Right? So the change in energy in presence of combined electric and magnetic field can be written as plus minus mu b E upon V if I write in a magnitude term, right? So the resultant. So if you know one more important thing, you can replace this as magnetic field because the ratio, the velocity can be represented as E by B, right? Because the ratio has unit of Tesla. So I can replace this by magnetic field also. So B can be written as E by V. B can be written as E by V. So I can write it as dE equals plus minus mu B, and this would be B, and I'm writing R. This means resultant. If this is resultant, that has to be the resultant magnetic field. So I'm not applying magnetic field. This is not the applied magnetic field. This is the ratio that has unit Tesla. So I'm using magnetic field over there, right? So when you do not have, so this is the energy. This is the total change in energy in presence of electric and magnetic field. So when this B vector is equal to 0, when magnetic field and electric field is 0, and if you excite electron from higher energy level to lower energy level, you will end up getting a single spectral line. So E2 minus E1 give you H nu, right? So when B vector and E vector does not equal to 0, now you are applying electric and magnetic field. So the change in energy will be, so E2 will change to E2 dash, and this would be energy of second orbit plus energy change due to electric and magnetic field dE to energy change in second orbit due to electric and magnetic field, because the applied field will act upon the second orbit also. So also E1 dash, so E1 will change up to E1 dash, and this would be E1 plus dE1. So the total energy in second orbit in presence of electric and magnetic field would be this much, and the total energy change in first orbit would be sum of this much, right? So are you still with me? Because I think I have shared very much complicated idea to you, and I think it is purely classical whether it is or not. So the difference in these two energy gives you multiple spectrum. So okay, I am writing this here. So E2 dash minus E1 dash is equal to E2 minus E1 plus dE2 minus dE1, right? So this will give you a, let us assume this is a nu naught. This is a single spectrum constant frequency photon. So E2 minus E1 can be written as H, this is nu, and this is H nu naught plus, so dE2 right here plus minus mu B BR. I'm not writing as, let us assume this is a B. I'm not writing R here because I want to write B2 plus minus mu B2, right? And minus plus minus mu B B1. So if you put second energy state, you have to use electric field induced in second orbit by velocity in second orbit, and this could be end up getting you B2 and likewise B1. So H nu is nothing but H nu naught, and if you take plus minus here, plus minus mu B, you will get B2 minus B1. So nu is equal to nu naught plus minus mu B upon H dB, right? I'm writing as dB whether it is delta B. So this is the shift in frequency. So this is the frequency shift, and this is the splitting constant. This is the constant frequency of photon, and this is the cause. Because of this term, the frequency is changing, right? And the ratio of Bohr's magneton upon Planck's constant is splitting constant in my sense. So if you find any mistake in this video, you can actually comment down below, and I am going to add the rate 3blue1brown.